Hello, hi, how are you? How are you feeling today? Good morning, wake up. Good afternoon, good evening. Are you tired? This is Tasien. I'm here again. Welcome to Tasien's class. If you like my videos, I hope you are going to do like I like. If you don't like, do like. Today's video is so bad. Let me know that the video is bad. And if it's your first time to be here, please don't forget to subscribe and turn on notification bell so that you will get notified anytime we upload a new video for you to watch. In today's presentation, I will be talking about a family of functions that makes life easy when you are coding or when you are trying to summarize your data. These functions are awesome. I'm telling you, you can just make your summary of the summary statistics in just one line of code, and then you get everything done. This family of functions, it is a family called apply functions. We have a function called apply, and the other one is L apply, the other one is S apply, the other one is V apply, and the last one that I'm going to be talking about today is the T apply. Guys, I'm telling you, these functions are, when you use them, you just write one row or one line of code, and you can do many things. You can summarize your data in just single line. Guys, don't go. Learn with me. Watch the video from start to the end so that you can understand everything that I'm going to be talking about today. Welcome. Let's start. Let's go. Yeah. So let's start with the apply function. But before showing you guys how to use this function, let me first define a matrix here. I call it A. A matrix A. It's a matrix. If you don't remember how to create a matrix, please go back to my previous videos and see how to create a matrix. And I want to create a matrix here formed by a sequence of numbers from 1 to 10. And these numbers, I want to store them in a matrix of two rows, and then of course with 5 columns. I have my matrix here, matrix A. Let me show you how it looks like, guys. This matrix here, you can see it. It's numbers from 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 10. I have this matrix. So let's say that I want to compute the sum of elements in each row or in each column. If we can use the knowledge that we already have from my previous videos, we can use, for instance, a for loop to make this, or we can create a function to make this. But now we are going to use the apply function, and we can do it in just a single line. How can we do it? We just write apply. This is the apply function, and the apply function needs an object. And the object that we want to use, this apply, it's not well written, it's with 2p. Apply, and the object in this case it's A, and we want to apply the function sum to its rows. If we want the rows, we put 1 here to specify that it's rows, and the function that we want to apply is the sum function. So in summary, the function apply, it needs an object and a function. In this case, the object is A and the function is the sum function. And we want to apply this sum function to the rows of the matrix A. So if I hit enter, tada, I get these values. we have 25. It's 1 plus 3 equal 4. 4 plus 5 equal 9. 9 plus 7 equal 16. And is it 16 or 17? Yes, 16. And then 16 plus 9 equal to 25, guys. I get this 25. And if you sum these values, 2, 6, 6 plus 6, 12, 12 plus 8, 20, then 20 plus 10 equals 30. This one. So, and in just this single line, we get the sum computed. We don't need to write the for values from 1 to no, we don't need it anymore. And if we want to compute the sums of elements on the column, instead of using 1 here, we put 2 to specify that we are on columns, not on rows. Then like this you get those numbers. This means this 1 plus 2 equals this 3, and this 3 plus this 4 equals 7, and this 5 plus this 6 equals 11, and this 7 plus 8 equals this 15, and finally this 9 plus 10 equals 19. Yeah, that's how the apply function works. But we can also need to define our own function to use. Here I'm using the function sum, which is a built-in function in R, but we can create our own function and use it. So how do we do it in this case? In this case, let's say that we want to compute the squared value of elements through rows or through columns from this matrix. So we will just write apply, and we take our matrix and we want to apply the function that I'm going to create to rows, then 1, and then function, and the function will take a value x. What does this x means? It means x will be elements of A in each row. And what do I want to do? I want to compute the squared value of each element on rows. Then I need x power 2. Then if I hit enter, tada! So you see, I get these numbers. It means like these numbers, this column here is the squared values of the first number, the numbers on the first row in this matrix A here. So you see 1 power 2 is equal to 1 here, and 3. Let me make this one. Don't know how I can make it easier to see. Let me open this vector here. Yeah, and still we are not going to see it well, but we can try it. Yeah, like this. So you see we have like 1 power 1 equal power 2 equal 1, and 3 power 2 equals this 9, and 5 power 2 equal 25, and so on. And when we go to the second row, we have 2 as the first element here, and 2 power 2 equals 4. 4 power 2 equals this 16, and 6 power 2 this one 6 power 2 equal to 36, and so on up to 10 power this one. Is 10 power 2, which is equal to 100. So you see, the function apply makes things easy. You can compute whatever you want in just one row. That's how the function apply works. Do you have any question, guys? If you have a question, write it in the comment, then I will answer it. Yeah. Or you can write to me through my email or find my contacts in one way or another. Then text me and let me know what the problem is. But that's how we can use the function apply. Let's see the next function in this family. Yeah, so guys, the other function that I'm going to talk about today is the lapply function, and I'm going to illustrate how to use this function using a built-in dataset in R called iris. Maybe we can view the iris dataset before, and I think with this screen like this we can't view it well. I need to make the characters a little bit smaller. I'm sorry if you don't see it very well, but I will make it bigger again, but make it smaller so that you can at least try to see how the iris dataset looks like. Let me clean first this one, and I make this one bigger. And if I type iris here like this and click enter, I get the dataset ready here. So you can see this dataset is formed by how many columns? 1, 2, 3, 4, and 5. 5 columns, and maybe some of you are not seeing it because they are too small, but there is a way to investigate what we have in these data sets. Let me make the characters again bigger for you guys to see it very well. I zoom in and zoom in, make it big, and again zoom in, big, yes, and again big. Sorry, big. So let me do this steer iris like this. If I do this like this, maybe zoom out a little bit. Yeps, and zoom out a little bit because this is too big. Zoom out, yeah, and here we go. Here we go. We have a data frame of 150 observations and 5 variables, and those variables, one is called the sample length, and it has numeric values as you can see here, and the other one is the sample width, and it has numeric values also, and the next variable is the petal length. It also has numeric values, and the next is the petal width. It also has numeric values, and the last one is the spaces. We have how many spaces? It says that we have 3 levels. It means we have 3 spaces, and then so that's the kind of data set that we have. And I want to, let's say that we want to get the mean value for each of the 3 variables which are not factors, or each of these 3 numerical variables: the petal length, the sample length, and the petal length, and the petal width. So if we want, for instance, to find the mean of these 4 variables, then we will need to use this lapply. Let me clean this again, then show you how we can do it. I clean this so that we can get a space. Then you have to write lapply, and what do we want to do? We need to apply our function to 4 columns of our iris dataset. Then it's from 1 to 4. 4 columns. And what is the function? Then you write function, and let's say that we want to calculate the mean function x, and then you specify the function. Let's say the mean. mean value. And which mean value of what? Mean value of the iris and the iris values for all the rows and the x columns. So what this function do, it will take x's from 1 to 4 because it means we need values on the columns in this range 1 to 4. Then we will take x from 1 to 4. One first column, second column, third column, and the fourth column, and we apply the function mean to those columns. If I hit enter, baba, I get the results here. So it says that we have a list. The result is a list, and the first element in that list, it is this value. It means that the first column has the mean equal to 5.84333, and the second column, the third column, and the fourth column down here. So, and then we get the mean of all those variables in just one line. And let's say that we don't only want the mean, we want all the summary statistics for those variables. We can do the same. We use always the apply function. Let me copy those things. Then instead of using mean here, you can put summary. And if I hit enter, tada, our results are here. So you see, we get a list of summary statistics for each column, for each variable in our data set. It means for the first variable, we have this summary statistics, these ones. We have the minimum, this minimum, the first quartile, the median, the mean, and the third quartile, and the maximum. What if we want to get the standard deviation, guys? The same thing. So we can do the same. I'm copying our thing. Then I change the function here. I put the standard deviation. Standard deviation is SD. Then the values that I will get, then in this case they will be standard deviation. So you see, this apply make things easy, and you can summarize a big data set in just one line. But what I don't like with this function is that it stores the results in a list. There is another better function to this one. I mean, in my case, I consider it to be the best, the better one than this one, because it does the same things, but the result is a bit readable, easy to read. So it's the function sapply. So let's see how to use it, guys. Yeah, if I change my function here to sapply, because the functionalities are the same, then sapply, they work in the same way, but the results are presented in different formats. Like for the apply, if you have seen it, all the results are given as a list. You see, list for each variable and each summary statistic in a list. Which is a bit hard to read. But if I use the sapply, the result will be much better to read, easier to read. Let me hit enter. So you see, so if I click enter, I get these values like this. I get 4 values, and those values are standard deviations, because the function that we are applying is the standard deviation. They are the standard deviation for our respective 4 columns, meaning that the first element for the the first column, first variable, the second element for the second variable, and the third for the third, and so on up the fourth for the fourth variable. Yeah, and to see its magic way and its readability, let me apply the function summary to this one. Then sapply, instead of using SDS here, I want to use summary, summary like this, and then I create enter. So you see, I get a matrix of 4 columns, and each column is the summary statistics corresponding to each variable in our data set. This means that the first column in this matrix is the summary statistics of our first variable in Iris data frame, and so on. So if you compare this matrix, how to read this matrix and how to read these ones, this with the add apply, we got the result that looks like this. Well, yeah, so like this. It was like taking the results into a list, and it's a bit harder for me to read, and it takes a bit much space for storage. But for this one, a matrix is easier to read. So the sapply and lapply, they works in the same way. You can use them the same way depending on how you want to your results to look like. If you want the result to be in a list, use lapply. If you want the result to be in a vector or in a matrix, then use sapply. Yeah. So let's see the next function. Yeah, but before seeing the next function, let me talk about this. We don't always need to have a predefined function to use in our sapply or lapply function. We can also create our own functions as we have done for the apply function. For instance, let me take one example. I am going to clean these ones. I clean this. For instance, let me take one example. I take sapply, and I have a sequence of numbers from 1 to 4, for instance. And to these numbers, let's say that I want to compute the logarithm of these numbers. Then I will write function x, and to x, for each x I will compute the log x like this. Then if I hit enter, tada, I will get the values log x. And this can be also done without including this function here, this function. If you leave the function, this one function like this, and you then in this case you remove this also, the x, and if you just write like this sapply, and you want to apply to these numbers the function logarithm, then you click enter, tada, get the same result. And let's say that you wanted to specify the which base, because the logarithm, you may need the logarithm in base 10, logarithm in base 2, or logarithm in n numbers. So then you have to specify, you may need to specify the base. Then let's say that we want to work in base 2, then you type base equal 2 like this. Tada. So you see, like in base 2, you know that logarithm of 2 will be 1. Logarithm of 4 will be 2. So you see, yeah, easy. The sapply is just awesome function. So now guys, we can go to the next function, and the next function will be the vapply. So the vapply is also used in the same way as the apply and the vapply, and the difference is that you specify what you expect the outcome to be. For instance, in this previous example here, and if I change and I put v here, then the function becomes the vapply. Then I can specify what I expect the results to be by adding, let's say for instance, numeric, then for that it returns an error. It says that the values must be of rank 4, but function results in rank 1. Oh, oh yeah. So then it means that the results here, I have specified the bad number here, then should be 1 because I only have one vector. Then 1, that you get the results. The values are numeric and they are in just one vector. That's it. Now there is no other difference between the sapply, lapply, and the vapply. The difference is only how we want our results to look like. If we want the results to be in a list, then use lapply. If you want the result to be in a vector or a matrix, then use the sapply. If you want to specify the output, then use the vapply. But then otherwise there is no other difference. So guys, I think you can see that these functions are very useful. So the next function, guys, I'm telling you, it's just, let's see how we can use that one too. It's the tapply function. So I will need to clean this one so that we can see how to use it for another data set. Let me clean it. Yeah. Okay, so this function is the tapply function. Sometimes we need to summarize a data set like the iris function that we have been seeing shortly, not shortly, in some units ago. It has one variable which is a categorical variable which has factors, and we may need like to summarize, but summarize based on each space. For instance, like we may need to summarize, let's say, the petal length based on the spaces. So how can we do it? So then we will need, in this case, to use the tapply. Then tapply. So let me say that then what do I want to do? I want to summarize the iris, and the iris, let's say the petal width, and I want to summarize it based on the spaces, and the spaces are in iris spaces like this. And what do I want? Maybe let's say that I want the mean, or I want the maximum, or I want the standard deviation. Let me say that I want the mean. Then I type mean here. Then if I click enter, tada! So you see, the function is just awesome. It displays that for the setosa spaces, the mean value for the iris petal width, mean value for the petal width is just 0.246, and for the very this, how to read this one, very very scholar. I don't know, I'm not biologist, guys, I'm sorry. The mean value is this one, and for this space Virginica is the mean value is just 2 points like this. So you see that the apply function is just awesome. So you see how this function is just awesome. It's very useful. And this function, it can also be used when you want to combine two functions. You want to like calculate the summary statistics using different two functions. For instance, for this one, I have been calculating the mean. What if I want to calculate the mean and the standard deviation only? I don't need other summary statistics. I only need the mean and the standard deviation for this petal wide. How can I do it? You just do like this, and what do you add here? Instead of typing mean here, let me clean it. I clean the mean. You just say that function x, and you specify which function. Then in this case you will specify that you need two functions. You need mean x, and you also need the standard deviation, then sdx, and I don't know if all the parentheses are here. This for this and this for this. Yes, enough. So you see, I combine the two functions, the mean and the standard deviations. I store them in a vector by using that command C, and then I apply those two functions to this data set, this petal length, and then they should be categorized into spaces. Then if I hit enter, that unexpected comma, yes, there is an error here. There should not be a comma here. Yes, there is no comma there. Then enter. Good. Yeah, so you see, then in this case there is data here. It says that on the setosa spaces, then this first value here will be for the mean, and the second value will be for the standard deviation. And this for now the other space is very color. Then this value for the mean and this value for the standard deviation. For Virginica, this value for the mean and this value for the standard deviation. So those guys, you see, these functions are very useful. Thank you. I hope you can see that these functions are just awesome and useful, and I hope that you will be using them in the future, or when you will be summarizing your data sets. So guys, that's enough for today, and I hope you have enjoyed today's video, and hope to see you next time. Bye.